So for versus while. Draw a table. Students often ask me which loop should I use. The answer depends on the problem. So here's the definition for loop and while loop. For loop is used when iteration count is known or when iterating over a sequence, list, string, range, etc. Okay, and while loop is used when repetition depends on a condition evaluated at runtime. Good when number of iteration is unknown beforehand. Okay, so here is a difference. Okay, so here when to use when we know the iterations, and here in while loop condition based repetition. Here syntax complexity simpler for sequences, and here need careful condition and updates. Risk lower, fewer infinite loops, higher possible infinite loops. Typical use traversing list ranges, waiting for event conditionals repeat. Use the right loop to make code clearer and safer. Suppose I want to print number 1 to 100. I already know there will be 100 iterations. So I will use a for loop. But suppose I am making a login system. The user can enter the wrong password any number of times until it's correct. I don't know how many attempts they will make. In that case, I will use a while loop. So when to prefer for loop? Number 1, iterating over elements of a list, string, tuple, dict case. Number 2, fixed number of iterations, example for I in range. Readability, index not required or use enumerate when index needed. Okay, so examples processing file lines, iterating test cases, list comprehensions. When to prefer while loop? Unknown number of repetitions, continue until conditions become false. Number 2, waiting for external event or user input. Number 3, implementing retries, polling, or loops driven by sentinel values. Number 4, be careful to update loop variables and break conditions to avoid infinite loops. So here we have definitions of break, continue, and continue else on loop. Break exit loop immediately useful for early termination. Continue skip remaining code in current iteration and move to the next iteration. Else on loop runs when loop completes, normally no break. Small example here we can see for x in range 1, 6. If x is equal to 3, break, else print completed. Okay, so output will no else executed because break occurred. So infinite loops. Now we are going to see one of the biggest mistakes beginners make, the infinite loop. Okay, a infinite loop, a loop that never ends because its termination condition never becomes false. Common causes: missing or wrong update of loop variable. Number 2, wrong condition logic always true. Number 3, external resource never changes, blocking wait. So I'll give you one example. You should write in your copy I is equal to 1 while I is less than or equal to 5. Print I. Before running, can anyone spot the mistake? First you guys spot the mistake, then I'll continue. Notice what happened. Python kept printing 1 forever. Why? Because we never changed the value of I. The condition 5 is greater than or equal to I always remained true. Fix it. I is equal to 1 while I is less than or equal to 5. Print I plus equal to 1. So here the output will be 1, 2, 3, 4, 5. Now, after every iteration, I increases by 1. Eventually, I becomes 6. The condition becomes false and the loop stops normally. Okay, it's a common beginner mistakes. Quickly discuss some mistakes I see almost every semester. Write one by one. Mistake number 1, forgot increment. Mistake 2, wrong indentation. Mistake 3, using equal to instead of assignment operator. Explain why it's wrong. Okay. Mistake number 4, putting break outside a loop. Mistake number 5, wrong range. Okay, so here are examples. Okay, so here is a bad example and here is the corrected one. I is equal to 0 while I is less than 5, print I. So here there will be infinite loop. So here is what we fixed. Okay, so here we have to write I is equal to 0, counter is equal to 0 while I is less than 5 and counter is less than 100. Print I plus equal to 1, counter plus equal to 1. So now the code will run. Excellent. Now you have learned almost everything about loops, but now comes the topic that every university exam includes: nested loops. We will learn how loops work inside other loops and then we will use them to create beautiful pattern printing programs that are frequently asked in exam and coding interviews. Let's continue. For this section, don't just type the code, draw the loop execution on a whiteboard or digital tablet. For example, I is equal to 1, condition true, print 1, I is equal to 2, condition true, print 2. Loop examples and how to avoid them. So here is a bad infinite loop which we should avoid. Here we have I is equal to 0 while 5 is greater than I. Print I. So here is the missing part which can create infinite loop. Okay, and here is the corrected part. I is equal to 0, counter is equal to 0 while 5 is greater than I and 100 is greater than counter. Print I plus is equal to 1, counter plus equal to 1. So it updates loop variable by 1 and here are the fixes. Update the loop variable I plus equal to 1. Use break with safety counter. Test conditions before loop entry. So here comes the nested loop introduction and flow. Nested loops are loops inside other loops. Flow: for each iteration of outer loop, the inner loop runs completely. Common in metrics processing, pattern printing, combinatorics. Okay, so here outer I start, inner j loop, process ij, inner end, outer increment. Okay, so what is a nested loop? A nested loop simply means a loop inside another loop. The outer loop controls the number of rows, the inner loop controls the number of columns. Remember this sentence because it will help you solve almost every pattern problem. Okay, so imagine you are in a classroom. There are 5 rows. Each row has 4 students. First, you go to row 1 and count all 4 students. Then row 2. and again count all four students. The outer loop changes the row. The inner loop goes through every student in that row. So open your VS Code, your first nested loop program. Write the code for I in range bracket 3. I mean in parenthesis write 3 colon, press enter. Then for J in range parenthesis 3 colon, then press enter. Then write print I comma j. Before I run this program, try predicting the output. Okay, so the output will be 00010101112202202122. Notice what happened. When I is equal to 0, the inner loop runs completely. 0, comma 0, 0, comma 1, 0, comma 2. Only after the inner loop finishes does the outer loop change to I to 1. Okay, so pattern printing starts. Most students memorize patterns. Don't memorize. Understand the logic. Once you understand the logic, you can solve any pattern. So pattern one is right. You have to draw the stars parallelly. Okay, so you have to write the code for I in range 5, print star. So it will start like this. Okay, so pattern 2, if you have to draw, wait, if you want to draw a square pattern, so how many rows? Okay, so like 5 and columns also 5. Perfect. So the code will be for I in range 5, for j in range 5, print print star comma n is equal to quotation mark print. This is the most important explanation. The inner loop prints 5 star. The print outside the inner loop moves to the next line. Then the outer loop repeats everything. And for drawing the triangle pattern, can anyone tell me what changes in every row? Okay, think and answer me. Okay, so the answer is stars increases. Exactly. So for that, the code will be for I in range 1, comma 6, for j in range I, print star n is equal to comma, sorry, quotation marks, print. Okay, so here is that will run the code. Okay, and for an reverse triangle, now stars are decreasing. What should change? Tell me. So the code will be for a reverse triangle for I in range parenthesis 5 comma 0 comma minus 1 parenthesis colon and press enter. For j in range I, press star, press parenthesis, quotation mark star comma and is equal to quotation mark print. Okay, so that will draw. Okay, and if you want to draw a number pattern, uh, can anyone guess the logic? Guess and tell me. So the code will be for I in range 1 comma 6, for j in range 1 comma I plus 1, print j comma and is equal to quotation mark print. Okay, so it will run. Okay, so congratulations. You have understand these patterns. You have already developed one of the most important programming skills, thinking in terms of rows and columns. Now we are moving to another powerful concept in Python. Imagine writing the same code again and again. Doesn't that feel repetitive?